I'd start this with a picture of energy in the developing world and the importance of the cost. This is India, and if you look at the activity, you gather that the economic development in India could use some improvement. You'd also notice that their energy source is not very efficient here, and that just burning biomass is occasionally a big problem for the environment. The other thing to notice is that these are women, and these women are not particularly gainfully employed. Women in the world who have better jobs and become more independent make choices about reproduction and control population. It's one of the problems we're going to talk about here. For the developed nations, we have a different problem, but it relates to the costs. And here you notice that the ratio of government debt to the gross domestic product of some countries, such as Japan, is really over 2 to 1. U.S. is about 100%. So these countries who have increasing debts are beginning to stagnate their economic growth. Luckily, Taiwan is in pretty good shape compared to a lot of the countries. What to do about the debt crisis and the economic stagnation in the world? We have conflict. Conservatives want less spending and less taxation. Liberals want priming the pump with deficit spending. There's always been that conflict. But there is another alternative, and that is productivity growth. That is, if we can increase the GDP of these nations somehow, then we can increase their prosperity and their tax revenues as well and begin to conquer that problem. One way we might be able to increase economic productivity is with cheaper energy prices, cheaper energy. Here's an example that gives a clue about that, and that says that we've had economic recessions in the last few decades, often preceded by a spike in the price of oil. So it gives you the idea that, in fact, energy is a very important determinant of the economy. And in fact, several economists have done some analysis, and they seem to point out that if you could inject an extra dollar of energy into a GDP, into an economy, you could get $5 to $7 more increase in GDP. So there's an importance in cheap energy, both for the developing nations and for the industrialized nations. Meanwhile, we have a few other problems. We have the global warming problem. We have also the population of the Earth growing from perhaps 6 to 9 billion people, increasing the resources consumption, competition for food, and competition for energy. Here's an example of the Kuwait-Iraqi war over oil. All these things need attention. In my opinion, the big problem of global warming is the problem of agriculture and food production. In this example of the Rongbuk Glacier in the Himalayas, the glacier is disappearing. The glacier was useful because it stored water that was released slowly in the summer to enable agriculture to take place even in the dry seasons with no rain. That loss of water means a loss of food production. Let's look at the problem of population. This is a plot of, for each of 82 countries, the number of children per woman versus GDP per capita, GDP being close to income. So it's sort of strikingly obvious that those nations with relatively decent incomes per capita are the ones that have fewer children, less population growth, and in many cases lowered population growth from natural births. I sort of arbitrarily say, well, you know, if we define modest prosperity at about $7,500 per year, it's sort of clear that, you know, if we had the goal of helping countries achieve that level of prosperity, they would naturally decrease their fertility rates and have stable populations and avoiding sort of a runaway demand for resources throughout the planet. One of the important things that improves prosperity is energy, and I'm going to talk about electric energy here. Electricity is a very valuable energy source, more so than just thermal energy, more so than heat, because electricity is used for heating and cooling, for lighting, for washing machines, for commerce, for industry. It has many uses. Of course, prosperity depends on good government, a lack of corruption in government, depends on good education, health care, and so on. But an important and essential property of the well-developed, prosperous economy is electric power. How much? Well, in the U.S., we use about 12,000 kilowatt hours per person per year. That's quite a lot. It looks, if we look at that $7,500 prosperity number, it looks as if something around 2,000 kilowatt hours a year, or an average electricity consumption of about 250 watts per person, is one of those essentials to achieving the population stability and modest prosperity, and in fact a stable government that will help the world develop. Well, of course, this is known to all the developing nations, and they want to increase their electric supply, and they're going to do it. They're going to do it by using coal, because it's been successful in the past. Burning coal for electricity has been an economically successful and inexpensive way to get that electricity. And so the Asian countries specifically are going to increase that. We have about 1,400 gigawatts of coal-burning electric plants in the world today, and the plans are to double that number. So we want to do something else. Now, there's been a lot of talk in the U.S. and the UN and so on about encouraging nations not to burn so much coal to decrease their CO2 emissions. And here's an example from China arguing against that. They say, well, wait a minute. The U.S. and Europe and so on achieved their economic status by cheap energy, and they burned over 1,000 tons of, or emitted 1,000 tons of CO2 per person to get there, and China at 76 tons per person is at a considerable disadvantage. So if we ask countries like China to cut back on their CO2 emissions to save the planet, they say, well, wait till we get on par with the rest of the world. So the other problem we have with coal is that the particulate emissions from old quality coal plants kill almost hundreds of 100,000 people just in China. One of the ways that has been recommended to solve our electric problem is efficiency. Let's make our use of electricity more efficient. And there are certainly many opportunities to do that. But let's just take a look at this for a minute. Average electric consumption in the U.S. about 434 gigawatts. Suppose we actually decrease that to half of that and encourage all other nations to achieve that level of efficiency of use of electricity. Understand that all those other nations want a lifestyle similar to that of the developed nations like the U.S. And so if they simply use that goal of, say, 217 gigawatts of power, we're going to, double or triple electric consumption. So in many cases, we can certainly save on CO2 emissions by being more efficient, but we have to recognize that the rest of the world wants more electricity, not less. We need clean energy cheaper than coal. I think you realize that developing nations specifically need to have inexpensive energy to meet their goals. And yet, we keep trying to institute carbon taxes. And we've had meetings of the UN committee on this subject time after time after time. And it never works because the people need inexpensive energy. Even the United States Senate and House have not been able to agree to implement carbon taxes. How can we expect the rest of the world to do that? I'm a big believer that economics wins. Economics trumps politics. World trade among nations is more important than all the treaties that we try to put together. That's going to dominate. Let's look a little bit at costs for a bit. We're going to go through costs of a couple of sources. Here's coal. A new coal plant with good quality emissions, but CO2 emissions nevertheless, costs about $2.8 per watt of generating capacity. So how much is that going to be when we come to the cost of the electric power? Well, what I did was to simply use the present value of $2.8 and spread it out over 40 years at 8% to translate that into a cost for the capital. And that capital cost is about 2.8 cents per kilowatt hour. So that's an easy way to remember. Just divide by 100. So in this example, we predict that with that capital cost, the cost of coal for new coal plants is going to be at $45 a ton for coal, about 5.6 cents per kilowatt hour. Now, the picture on the lower left is one of those fancy new plants, the only one in the United States, an integrated gasification combined cycle plant, one that burns the coal in an oxygen atmosphere so that the effluent gases are only CO2 and H2O, so that you can get the CO2 out of the flue gas in order to capture it. But that, of course, raises the cost of electricity quite a lot. And this excludes even the cost of trying to store CO2 in the ground. Natural gas is the latest thing, but look a minute at the costs here. Right now, the costs are on the order of $4 per million BTU in Louisiana, but in Japan, they're paying $16. So there's going to be an opportunity for arbitrage. People are going to build pressurized liquid methane gas tankers and send that gas to Japan and other places. The other opportunity is the fact that natural gas provides heat at a lot less price than does oil, and so things like oil-powered generator stations are going to disappear. All of this increasing the demand for natural gas and increasing the price, which I predict will be at about $5 per million BTU. And in this case, with a combined cycle gas turbine, that's the kind that works like a jet engine. It turns the turbine and makes the generator spin, and then takes the heat and runs a steam boiler that generates electricity as well. That very efficient, 60% efficient combined cycle gas turbine is going to generate electricity at 4.8 cents a kilowatt hour. But many of the turbines in the U.S., at least, are the ones that can speed up quickly as necessary to compensate for wind lulls or solar clouds and so on. And those aren't nearly as efficient. They're going to run about 7 cents per kilowatt hour. Notice I'm very focused on economics here. What's happened in the world is the carbon intensity of our electric generation worldwide hasn't changed very much. We haven't been very successful yet in lowering that carbon intensity. What about nuclear power? Can that replace coal in this example? We're going to do a quick review of how a nuclear power plant works. You might remember from your high school that a big uranium atom, 235 neutrons and protons, absorbs a neutron and breaks into two parts. Perhaps the elements krypton and barium, releasing some energy. The inventor of the light water nuclear reactor was Alvin Weinberg, and he also convinced Rickover to power the very first nuclear power plant, which was a submarine, with that kind of a reactor. None had been built at that point. Rickover was a very driven, demanding, dominating person, and he managed to get that submarine and power plant built in about 6 to 8 years. After Eisenhower gave the so-called Atoms for Peace speech, Rickover was selected to also run the U.S. nuclear power program, and he used the same technology in commercial electric utility plants. Here's the first one in the U.S. in Shippingport, Pennsylvania. In the end, the U.S. installed 100 of these kinds of reactors. But they're all solid fuel, water cooled. And we're now in a situation in the U.S. where some of these aren't even competitive with natural gas. And so 2 of them just recently have been shut down.